the biggest exponent, so we divided by that. So each term got divided by x cubed. So 4x squared over x cubed is 4 over x, because x squared, x cubed, 1x left. There are no x's here, so that stays as 50, bottom is x cubed. X cubed divided by x cubed is 1. 85, no x's here, divided by x cubed, we're here. Then I just plugged in infinity. So this is saying that we have a horizontal asymptote at y equals 0. Because remember, horizontal asymptote is asking the question, what happens at positive infinity, what happens at negative infinity. Questions on this one? If you feel confident with this one, go ahead and go to number 2. That's what I'm going next, the one right below it. I'm going to be modeling that one up here, the one right below it. I want to pause for a second for myself and see if anybody has questions on this one. Again, if you're good, please attack number 2. I'll be modeling up here, one right below it. Okay. So I'll narrate a bit less, just to give those who are working on their own some time and space to attack this. Again, if you're needing support, don't hesitate to look up here. It will not always be this. In fact, we'll see some examples a little later in class where it will not be infinity over infinity, which is why it's, I think, crucial to do that plug-in step. Again, if you're on your own, you may want to verify once in a while up here. And if you feel like you've gotten this one, number 3 is the next one I'm going to do. Let me take some questions on this. Again, if you're done, you got it, go ahead and proceed to the number 3 right below it. If you have questions, let me know how I can be helpful. Okay, so no questions on here. Again, proceed to number 3, please. Eddie, go ahead, please.
Or do you want to say the limit?
No, this is the answer to this question, because we're just asking you what the limit is. I'm just previewing what's going to come next, where the question will say, find the horizontal asymptote. You'll do all this exact same work, because remember, the horizontal asymptote is what happens at infinity, what happens at negative infinity, except in that case, the answer would just be y equals 4 over 5.
So we don't have to write like you did on this one. On the first one, you like wrote it off.
No, this is the answer right here. The limit of blah, blah, blah equals 4/5.
Oh.
Yeah. This is just there to preview coming next. Questions? Okay. Let me attack number 3 right below it. Let me attack number 3 right below it. So we got limit as x goes to infinity, 3x cubed minus 23 over 4x minus 1. Again, I'm not going to narrate much. I want to give people the time and space to attack this. If you do have questions, though, don't hesitate to ask. Some of you might be on autopilot and you're dividing by the wrong thing, so verify you're actually making the correct division step.
I thought it was the greatest.
Look back at the notes, see what we said. Thank you. Greatest exponent in the denominator. A lot of people are going to go onto autopilot on the exam too. So now we're trying to work the kinks out early. Make the mistakes early when the stakes are low. Infinity can be the answer to the limit, but if we asked what is the horizontal asymptote, the answer is horizontal asymptote is none, because horizontal asymptote is y equals a finite number. Infinity is not a finite number, so it is not the horizontal asymptote, but it is the answer to the question, what is the limit? Questions on this? Questions on this before we move to the next level? Okay, so let me talk a little bit now about vertical asymptotes and holes, and then I'll do a few more problems. All right. So, vertical asymptotes so vertical asymptotes, x equals something, finite number And a vertical asymptote occurs at x equals c. Remember, asymptote is a line. If the limit as x approaches c is either plus or minus infinity from the left, the limit as we approach from the left is plus or minus infinity, and the limit as we approach from the right is plus or minus infinity. So if this happens, then we have a vertical asymptote. Right, so let's look at what this looks like in terms of a picture. So we're talking about here with the picture is you have a something like this. So maybe this is, I don't know, x equals 6. And here's an example of vertical asymptote. Y. The limit from the left, positive infinity. The limit from the right, negative infinity. Another example with a picture. On the third shelf, second shelf. Again here, x equals 4, vertical asymptote. Y, limit from the left is positive infinity. Limit from the right is also positive infinity. Another example of vertical asymptote. Let's have some more complicated pictures now. You could also have a case where this happens. So here you have a horizontal asymptote here at maybe y equals, I don't know, -7, because that's what happens when x goes to negative infinity. Then you have this picture going on here. You have another horizontal asymptote at maybe y equals -1, because that's what's happening as x goes to positive infinity. And then you have a vertical asymptote at x equals 3, because the limit from the left, positive infinity, limit from the right, positive infinity. Questions on this? We're going to give you things like this and ask you to analyze it. Okay? And the last piece is, or are, these so-called holes. And we talked about this before in terms of how the holes are not really affecting the limit. They affect more about whether the function's continuous or not. And the holes